Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to be looking at angle measurement. Now, measuring angles with a protractor is often quite difficult for students. It gets confusing as to which number you're reading. And you'll hear teachers often say, is it more than 90? Is it less than 90? To help them know which of those numbers to use. But they also have difficulty if they are practicing with one type of protractor and then see a different kind of protractor on a testing situation or are given it in a new class or a new year. So to make sure that your child is proficient at angle measure, we want to make sure they are proficient using any type of protractor they get and understanding same and different. So in this video, we're going to look at a few of these ideas and think about how we help your child with this, with using. Now, one of the things I do with kids is I give them each a protractor, and it may start out to be the same one, and have them just list everything they can about that protractor. What do you notice about this protractor? So as you look at this, you can see things like there is 90. There's the numbers going in both directions. There's little lines that mark off the degree measure. This one has a ruler at the bottom. It has a ruler in inches at the bottom, one in millimeters here. So we see all these different pieces. Now, once they've done that with one protractor, I give them a different protractor. And now it's not just telling me everything about this, it's what's the same and what's different between these. And throw in a third protractor. And throw in another one. Now, what will be the same about every protractor that they get? And when they get good with these semicircular ones of identifying them, see, I can also throw in a circular protractor. What's going to be the same about all of the protractors is all of them have a place that the vertex will go. So as you're looking at some of these, let's see if I can get a pointer here for you, right? Here's where the vertex goes on this protractor. Here we have this rhombus pointing down. It would go there. Here, do you see the little plus sign there where that vertex goes? Here's a little circle. Here again are these perpendicular lines coming from 90 where it goes. It doesn't always go at the bottom of the protractor. Just like our rulers don't always have 0 at the edge of the ruler, the student needs to be mindful of that. And then we always have these numbers, but we have the degrees marked off in multiples of 10, 5s, and 1 degree units. Let me show you here again. 10s, 5s, and 1 degree units. So that will be true of whatever protractor they're given. Now, let's just look at using a protractor to measure. And I have several angles on this sheet of paper. It really doesn't matter which protractor we use. I'm going to use, let's use this orange one. Okay, I've blanked out the name, not sponsored by anyone, okay? But as I said, there's a place where the vertex goes. Now, I remember spending a lot of time lining up the ray on the 0 and then trying to figure out which number to read, okay? But as I said, the vertex here, I can put the ray through any of those decade numbers. Let's say I put it here, and remember, these go in multiples of 10. 10, 20, 30, 40, 50, 60, and this is 70 degrees. It doesn't matter whether I have the protractor here. If I have it aligned at 0, you can see it's 70 degrees. I could have it over here. Still 70 degrees as I go through. In the measurement, the length measurement, linear measurement video, we talked about the broken ruler test that many of your children are given. They break the end off a ruler and see if they still know how to use the ruler to measure. You don't have to have the ends. Same is true with a protractor. I should be able to break the ends off the protractor where they can't align at 0, but they could still use it to measure. Now, the same would be true here for this angle. I know there's a point, and let's use a different protractor. There's a point, the vertex of the angle, where the vertex goes on the protractor. I can line up, take it through any one of these, which I don't have to go through a decade at that nice 10, but it's much easier to count, right? And then I can go, 10, 20, 30, 40. And they already know they may need to extend the line, but it looks to be about 48 degrees. Do the same thing. Whatever protractor I'm given, there's a spot where the vertex goes, and I'm focusing on the space in between the two rays, not on the numbers. That's where we want your child focusing when they measure with a ruler. Focus on the size of the units, the space, not just the numbers. Same is true here. Focus on the space, the degree measures, not just what number to read. They tend to make errors when they do that. Okay? And if you notice, because of the way I'm doing this, I'm not having to turn the paper. I would have been turning the paper all around because I had to align at 0 when I first learned. As long as I have the vertex in the right location, I don't have to keep shifting my paper. The ray goes through here, and you can see I could put the ray anywhere, including the 0 line, and still be able to get the same angle measure. What happens when they get this comfort with it and the focus, it's okay if I do get a picture of a protractor with 0, it's aligned at 0, and you're reading. That won't throw me because I'm, again, looking at the spaces, the multiples of 10, the multiples of 20. Now, key angles and other key terms. If you notice this one, I bet you can predict what it is, right? I can line it up. I've got the vertex. I'm going to put this through here. Okay. Let's see, I'm looking upside down. How am I doing here? This should be a 90-degree angle. Now let's do it at a different location, see, and if that'll still be a 90-degree angle. Yep, 10, 20, 30, 40, 50, 60, 70, 80, and 90. Now, this is a right angle. 90-degree angles are right angles. And I drew it in this orientation on purpose. Because I've had children, I'm not sure if this is the right, but this was a right angle to them. This is on my right, so maybe this would be the right angle to you. Yeah, right angle. Then they call this a left angle and a top angle. And what we need them to know is no matter the orientation, if it is a 90-degree angle, right, and I can test it by just putting the corner of my paper in there, I don't need a protractor. All corners, right, are going to be that 90-degree. If it's a 90-degree angle, it's called a right angle. So here we have right angle. And this is 90 degrees. More than right, and that's why we use this to help the children know which set of numbers to use. This would be an obtuse angle. Okay, and each of these were less than 90. These are each acute angles. And there's all kinds of little stories and sayings to help them remember that. I think this was a 70-degree angle. Okay. Now, again, for a child to determine if an angle's acute, obtuse, or right, they don't have to have a protractor. They don't need any of these. If they're only determining whether it's one of those three things, as I said, I can use the angle of paper. I can use the corner of paper If it's less, let's just use one sheet here so you can see through it, right? If it's less, doesn't quite make it to the corner like this one does. Can you see that line through there? It's an acute angle. If the corner fits exactly into it, right angle. If it goes beyond the corner, beyond, obtuse angle. So helping your child become proficient with angle measure, it's more than just aligning on a protractor, aligning to zero and reading numbers. It's understanding that I could move this around, but there's a place the vertex must go. I can put a ray through one of the degrees and count to the other part where the ray hits. I can use sheets of paper, the corner, as my benchmark for 90 degrees, and then determine acute, obtuse, and right. And as they become more comfortable with these angles, they won't need the protractor to determine it. I hope you found this video useful. If so, please give it a thumbs up. Please share. If you'd like to know when other measurement videos or other math videos are available, please click on that notifications bell and subscribe to the channel. I'd really appreciate it. Thanks so much for watching.